Okay, I don't have my mic with me. I'm traveling, so hopefully you can hear this. We're going to write a regular expression to find every possible variation of email addresses, hopefully. So let's get to it. All right, so we're going to assume it's in some body of some other information. So we'll just type in some random crap here. And let's get some HTML data for good measure. All right. Now we want to put in some email addresses. So let's put in here. Put in one here. And first, middle, last. All right. That's probably enough for now. I think that covers most variations that we might see here. We'll do this as well. It's somewhat common to have. I have an existing regular expression that I use, and I've made some others before, but let's just build one from scratch. So an email address should always start with a letter, a number, or I mean, it should be a letter or number in almost every case that's plausible. So we would start that by saying the word boundary here. And the start of some word. So word boundary. Let's go in here. This is a word boundary. Matches without consuming any characters. It's identifying a spot. It's not matching or returning anything. This, W, any word character, meaning a letter, a number, or an underscore. Let's find that here so we can read the summary. Any word character. Now, if we say plus, that means find one or more. we said star that says find 0 or more. We'll stick with this. Now, from here, then we want to find, in some instances, we want to find an @ symbol, right? Another thing we want to look for that I should have put at the front here is there should be a space in most instances, right? Unless it's within HTML and there's some kind of character, non-word character, which is possible, right? It could be a greater than caret. But we can account for that too. And so we'll use a look behind. And we'll say find a space character or find a non-word or non-word. So capital W finds the opposite. And that's the case for pretty much everything in regular expression. So this \s means find a space character, which could be any white space character. But if you say capital S, any non-white space character, which is useful. And honestly, now that I'm thinking about it, yeah, like that's an issue with this regular expression and my other one, that you really need to know whether or not you're parsing HTML data, if it's up against a caret or something like that, because it's troublesome to account for that with a non-word character, because it could be something else, right? So I'm actually just going to say or that. Okay. And so we have, how many matches do we have here? 3. We get this email because these are all word characters. We get this one because it's right up against the @. We're missing this one because a hyphen is not a word character. And we're missing these for the same reason. But let's keep going. So from here, we know that we are going to find any non-white space character, right? So because there can't be a space between the end here. So we could just say this plus, that'll get us to the end, right? Again, the only issue that we might run into there is that if, yeah, see right here, we're picking up this HTML information that we don't want. So we need some sort of look ahead or something like that. Condition. Rather than doing that, I think it's easier just to say go on and then search for a period, because there's going to be a period for the domain, and that'll stop it. And then we could say all the domains are going to be letters, actually, right? They have to be. Letters or numbers. Yeah, no, a domain ending will have to be a letter. So then we could say, and it really should be undercase. But just in case it's not, we would do this. And let's look this up. So a single character in the range between A and Z. And trying to think of any possible issue we could run into there, but I'm not thinking of any. This seems to work pretty well. All right, so that's getting a lot of emails for us. Now we need to account for these other variations. So we could say, you know, that regex I was using earlier is super complicated for no reason. I don't think we need to do any of that. Let's back up a second and just, what about any non-white space character? We're getting this, but then that's fine because I can just move this to look for the caret first. Oh no, that doesn't work because of, yeah. That doesn't work because this is greedy. Um, hmm. If you're wanting to know what greedy means, mm, I don't know. It means greedy. Damn it. Hmm. Non-white space character. We could do that. Yeah, that'll still work. And then I could say as well as this. And as long as the email address has at least 2 characters, which it would, we should be able to then get a word boundary. Oh, let's see what's happening. This is our problem area here, right? So what's happening is starting from a word boundary here and going forward. And then it's seeing this at symbol, and then it's verifying that, okay, everything was okay up until we came up to this white space character because of this crap here. There's got to be a better way than this long string that I had, though. Let's keep looking at it. So we know that there will not be, yeah, that's accounting for the specific instance. Hmm. Hmm, hmm, hmm. All right. Ah, I know what we can do. I know what we can try anyway. So instead of making this, this greedy thing, we'll say find a minimum of 1, a maximum, I don't know, what's a good character limit for an email address? 15 plus 15 plus 5 maybe at the most, right? 10, 5, we'll say 50 characters. It should never be more than that. And then we'll say, and find as few as possible. Damn it, that still doesn't work. Hmm. Hmm, hmm, hmm. Alrighty, we will just count for these variations. I'd really rather not do it this way, but oh well. All right, so we'll say that, or find a period between it. So that gives us this, or find period, word, another period, another word, meaning we can have up to 2 dots, 3 names, something like that. That gets us this. And we'll do the hyphen as well. Let's make sure we account for 1 hyphen and 2 hyphens. So what we're saying here is this is an or statement. So it's saying find this variation or this variation or this variation or this variation. Or this variation will be a single hyphen. There we have it. I don't like this, but it works. Keep in mind that this look behind thing is a ES6 feature, I believe, for JavaScript. I don't know if it'll work in other, looks like it works in Python. Definitely, oh, it works in Perl, PHP as well, cool. Yeah, there you go. So hopefully this makes sense. If you're working on anything like this, feel free to reach out if you have any questions, I guess. Yeah.